All right, here are solutions to perfect problem 2 for Math 251. We're asked to find a bunch of derivatives. Kind of tells us how to find them. So for your reference over here, I wrote some formulas. The top one is the definition of the derivative. Bottom one's the difference quotient. So for part A, it asks me what? To find f prime of 7. So this is what I'm trying to figure out. In other words, find the slope of the tangent line to this curve f of x when x equals 7. Find that thing. How? Using the definition of the derivative. Okay, the definition of the derivative is over here. It gives me a formula for f prime of a. I don't want to know f prime of a, I want to know f prime of 7. Easy enough, I'll just change all the a's in this formula into 7s. So what I need to figure out is what is the limit as x approaches 7 of f of x minus f of 7 divided by x minus 7. Figure out this limit right here. Okay, well, I know what f of x is. It's given to me in this problem. It's the square root of x minus 3. And I can figure out f of 7. F of 7, just look up here, f of x is this mess. So f of 7, change all the x's into 7s. What I would get is it's the square root of 7 minus 3 divided by x minus 7. And if you take this one step further, just kind of clean things up, leave my limit alone here, leave the square root of x minus 3 alone. This term over here, 7 minus 3 is just 4. Square root of 4 is just 2. So I can simplify to get this thing to look like this. And the good news here is this is a limit that we can figure out. This is very similar to problems we've done already. We can evaluate this limit. Try to evaluate it by changing all the x's into 7s, but if you do that, you'll get 0 divided by 0. Damn. All right, so I can't just change all the x's into 7s. I got to do some sort of algebra. It's this x minus 7 that I want to get rid of, so I kind of need to make an x minus 7 pop out of the top. And the trick that we learned for how to do that is we're going to multiply the top and the bottom of this fraction by the by the conjugate of the numerator here. So instead of the square root of x minus 3 minus 2, I'm going to do the square root of x minus 3 plus 2. And if I do it to the top, I better do it to the bottom also, so I'm not changing the value of this limit. Okay, maybe I drop down to the next line here. That is equal to the limit as x approaches 7. If I FOIL this mess all out on top, square root of x minus 3 times the square root of x minus 3 is just x minus 3. Negative 2 times the square root of x minus 3 is negative 2 times the square root of x minus 3. Positive 2 times the square root of x minus 3 is positive 2 times the square root of x minus 3. And finally, negative 2 times positive 2 is negative 4. I'm not going to bother foiling out the bottom because it's this x minus 7 I want to get rid of, so I want to leave that factored out because hopefully I'll be able to get an x minus 7 out of the top, which I can then cancel with that x minus 7. Well, let's see. I got negative 2 of these root x minus 3 things and positive 2 of these root x minus 3 things. Those cancel out. So what I'm left with on the top is an x, a minus 3, and a minus 4. In other words, an x minus 7. That is very good news because this x minus 7 can cancel with this x minus 7. This is the one that was causing problems. The whole purpose of this problem was to get rid of that x minus 7. I just did. That's good. So we can say that this is equal to the limit as x approaches 7 of 1 divided by the square root of x minus 3 plus 2. Minor little point. What I have written here, this fraction is not the same as this fraction. However, the limit as x approaches 7 of this fraction is the same as the limit as x approaches 7 of this fraction. The nice thing is this is a limit I can evaluate. I can evaluate it by changing all the x's into 7s. I get 1 divided by the square root of 4 plus 2, which is 1 divided by 2 plus 2, which is a quarter. In other words, the slope of the tangent line to this curve at this point 7 is 1/4. If you graphed this graph and you put a little dot when x equals 7, and you drew the tangent line to this curve at that point, what you would be drawing is a line that has a slope of 1/4. All right, moving on, maybe a little bit quicker. B says do the same thing, but use the difference quotient. Fine. Using the difference quotient, I get that f prime of 7 is the limit as h approaches 0 of f of 7, I'll write it out, f of 7 plus h minus f of 7 divided by h, which is the limit as h approaches 0 of f of 7 plus h. Well, here's f of x. If you change all the x's into 7 plus h's, you'll get the square root of 7 plus h minus 3. 7 plus h minus 3 sounds like h plus 4 to me. All right, 7 plus h minus 3. 7 minus 3 is 4. Got h plus 4. Minus f of 7. If I put a 7 up here, I get the square root of 7 minus 3, which is the square root of 4, which is 2. Get to here. And on the bottom, I just got an h. I'd like to change all the h's into zeros, but that won't work. I get 0 over 0. Damn. Well, I hope there's some sort of trick I can do to cancel out this h on the bottom that's causing the trouble, that's causing me to divide by 0. In fact, there is. It's very similar to what we did up here. Multiply the numerator and the denominator by the conjugate of the numerator. What I'm saying is I'm going to multiply the top by the square root of h plus 4 plus 2, and the bottom by the square root of h plus 4 plus 2. And what you'll see is that that was a very good choice, because things are going to cancel out very nicely. If you FOIL this mess all out, root h plus 4 times root h plus 4 is just h plus 4. Root h plus 4 times 2 is 2 root h plus 4. Root h plus 4 times negative 2 is negative 2 root h plus 4. Those cancel out. And then I got negative 2 times positive 2 is negative 4. What I'm left with on the top is h plus 4 minus 4. On the bottom, I got h times the square root of h plus 4 plus 2. You could distribute that h if you wanted to, but you don't want to, because we want to cancel out this h down here. So don't distribute it. It'll make it harder to cancel out. Leave it like that. H plus 4 minus 4 is just h. So this is the limit as h approaches 0 of h divided by h times square root of h plus 4 plus 2. And that limit is the same as the limit as h approaches 0 of 1 over the square root of h plus 4 plus 2. Now that I've canceled out these h's, I can evaluate this limit, change all your h's into zeros, and you'll get 1 divided by the square root of 4 plus 2, which is 1 over 2 plus 2. Sure, I'll write it, which is 1/4. Nice, same thing I got before. That's a good thing. If we're figuring out the same thing using two different methods, hopefully we'll get the exact same answer. We did. Moving on, part C. I don't know if part C is more straightforward or less straightforward. Now you're asked to find g prime of a. So first of all, we're using a different function. Second of all, we're not finding g prime of 7, for example. We're using g prime of a. We want to use the definition of the derivative. The nice thing is I have the definition of the derivative up here, and it's written if you're trying to find f prime of a. So all I got to do is change all the f's into g's. What I'm saying is g prime of a would just be equal to the limit as x approaches a of f of x, which I know to be x squared minus 3x, minus f of a. Well, sorry, g of a. Well, if g of x is x squared minus 3x, g of a would be a squared minus 3a. And that whole thing gets divided by x minus a. What we're trying to do when we evaluate this limit is change all the x's into a's. And that's hard to do. Well, if you change all the x's into a's right now, what you'll see is you get 0 over 0. Damn, so I can't do it immediately. So what I have to do is figure out a way algebraically to get an x minus a to pop out of the top somehow to cancel with this x minus a on the bottom. Let's see if we can make that happen. Limit as x approaches a of... So the trick here will be I want to get an x minus a out of the top. These parentheses, I can take this. The trick will be to regroup terms. What are you talking about? Instead of x squared minus 3x minus a squared plus 3a, I'm going to write x squared minus a squared, and then I got minus 3x and plus 3a. So all I did was I took this negative and I distributed it through, and then I reordered things. I put the square terms together and the linear terms together. And the reason you want to do that is we'll be able to get an x minus a out of this, and we'll be able to get an x minus a out of this. So we'll be able to cancel out all our x minus a's. A couple different ways you can write this. I think the easiest way to write it is this is the limit as x approaches a of x squared minus a squared over x minus a plus negative 3x plus 3a over x minus a. Going from here to here might confuse you, but going the other way, think about it like you started here. I got fractions that have a common denominator. So to add them, leave the denominator alone and add up the numerators. That would get me from here back up to here. X squared minus a squared is the same as x minus a times x plus a. Negative 3x plus 3a. I want to cancel out an x minus a, so if I factored out a negative 3, what I'd be left with would be an x minus a. Let's go down another line. Or closer than it may seem. If you look at this fraction here, the x minus a's cancel out, and I'm left with x plus a. And if you look over here, these x minus a's cancel out, so I get a minus 3. And what I now have is a limit I can evaluate. I can change all my x's into a's. What I would get would be 2a minus 3. And if I do that, I have my answer. Might look a little weird, but what this is saying is the slope of the tangent line to this curve at some point a, I don't even know what number a is right now, is given by this equation. So if you did know what a is, if you want to know when a equals 7, for example, you could just change this a into a 7 and say it's 14 minus 3, which is 11. But for now, we just leave it like this, 2a minus 3. Part D, I believe, says do that same thing but use a different method. Is that true? Find g prime of a using the difference quotient. Okay, now use this form. Do that same thing you just did. Use a different method. The difference quotient tells me that g prime of a is the limit as h approaches 0 of g of a plus h. Well, let's see. This is g of x. So g of a plus h would be a lot like this, except everywhere I see the letter x, I replace it with a plus h. So what I would get is instead of x squared, I'd get a plus h squared. And instead of minus 3x, I'd get minus 3a plus h. So that is this part of the formula. But then you still need to subtract f of a, or in our case, g of a. Well, here's g of x. G of a would just be change all the x's into a's, subtract a squared minus 3a. Divide that entire thing by h. What a mess. Okay, so again, you try changing all the h's into zeros and it fails. You get 0 over 0. Damn, so I'm going to have to do some algebra. I'm going to hope I can do something up top so that when I simplify everything, there'll be an h kind of popping out of this that I can cancel with this h right here. Hope it works out that way. It will work out that way. It always will. So let's see it. Well, a plus h squared means a plus h times a plus h, which is a squared plus 2ah plus h squared. Negative 3 times a plus h, negative 3a, negative 3h. You can take that negative 3 and distribute it through. And then minus all this stuff, minus a squared plus 3a. Be careful, we want to distribute the negative sign to both of these terms, so that switches the sign here. think things will simplify rather nicely. Let's see. I got a squared here and negative a squared here, so those two cancel each other out. I got 2ah. It looks like the only term that has both a's and h's in it, so I'll leave that. I got an h squared. I don't have any other h squared, so I'll leave that. See, I got minus 3a, but over here I got a plus 3a, so those cancel out. Got a minus 3h and no other h terms, so I'll write minus 3h. And now I think we've gotten everything. We already got rid of this minus a squared with this plus a squared, and we already got rid of this plus 3a with this minus 3a. So it's all this stuff divided by h. Remember the original problem. The goal was to get rid of this h right here. That's what was causing the issue. So I want to cancel out this h. Every term in the numerator has an h in it. So what that means is I could factor out an h from each of those terms. 2a plus h minus 3. And cancel it with this h in the denominator. What I get is that I need to evaluate the limit as h approaches 0 of 2a plus h minus 3. This is a limit I can evaluate. All I got to do is change all my h's into zeros. I get 2a minus 3. Note that's the same thing I got up here. It's good news. It's a good thing when you get the same answer using different methods. That's all. That's all you do for now. This has more meaning than it might seem right now. Right now, it's an expression. It's our answer. We'll leave it just like that. And so that's finally the end of this kind of long problem.